We have today with us actually the CEO and co-founder of Temporal here, Maxime or Max, and really happy to have him here, and he'll be showing us a little bit of the Temporal framework with reliable infrastructure provisioning. And I'm really curious because before this talk, actually, I had not heard so much of Temporal except from some groups within SAP which were using it, right? And I didn't go through all the examples, so I'm really eager to learn about this. And with that, I will hand over to Maxime and give him a hand.
Maybe I'll try this approach. So just a couple words about me as you probably don't know me. I worked in a bunch of companies, but since 2002 I joined Amazon and Microsoft and back Amazon. So I spent at Amazon total 8.5 years, and then joined Google and started Temporal. At Amazon, I was responsible for Amazon messaging platform, which is practically the whole asynchronous communication layer that Amazon ran on for, I don't know, maybe they still run on that, I don't know. But it practically was a replicated storage for messaging system, which it was like 5 years before Kafka was even conceived. And later to a simple queue service, AWS simple queue service adopted that as a backend. And then later I was tech lead for Amazon simple workflow service. And Temporal is actually was born kind of as on the same ideas as the simple workflow service, but just to move those ideas forward. But you still can go to Amazon, check AWS simple workflow. And then I ended up at Google. After Google, not much to brag about. But I joined Google, and at Google we built a couple open source projects. One was ShareMe, which was not a messaging system. We can attract replace Kafka inside of Uber. We didn't succeed for non-technical reasons, but project is still out there. Maybe one day we'll select that. And then later we built Uber Cadence, and Cadence was kind of implementation simple workflow ideas, but using completely different software stack, written Go. And then later we started a company called Temporal, and it's fork of Cadence under the same MIT license, so you can use it for free if you want to. But we also have a company which provides the hosted offering. So besides I'm CEO, co-founder, technically I was engineer. I didn't mention single person before I started the company until 3 years ago. I was always tech lead or engineering, like staff engineering and so on. So besides we're talking about infrastructure, I just want to start from example, kind of textbook example, money transfer. Because we talk about transactions, we talk about we always use money transfer as an example. The problem is that these days we don't have a single database, we use services, and we have external APIs and we run transactions across time. So if you need to make sure that you can withdraw and then you deposit, and something fails in the middle, like the process crashes while you're trying to deposit, how do you end up in a consistent state at the end of the whole kind of execution? And this pretty simple code, 2 lines, how do you make it complete? And how do we do that? Standard approach is to add some resistance. We do engineers. We so practically start checkpoint and state to the database every time there is some change. So we do withdrawal, we save state. Okay, we end this state, right? Then we go and like do that. Problem is that and then this can recover that state. The problem is the moment we start doing that, they're not programming, like you don't have these 2 lines of code. They practically start programming the state machine. Right? We practically have state in the database, and we have a bunch of callbacks, and these callbacks create the state, and every external event becomes a state transition. You know, we clear it. And in most cases, it's not even like explicit model state machine. It's just a bunch of data, and you have like complex code, just a bunch of switch statements and if statements and so on. And then it's not just state machine. You need to manage multiple threads. parallel processes, and so on. And then you also need durable timers. And usually you do it just putting records in the database and pulling for those records out of the database. Or give me every record which has this timestamp and so on and so on. And because you practically need to do retries, you need to maybe recover things and so on. And then usually these things don't fit a single process, so you need to start sharpening them around to multiple processes. And you start bringing components like Zookeeper or other components like TCD, which can help you do sharding. And you already see kind of this complexity growing and growing. And then database stops scaling, so you need to shard the database. Other thing is that you usually don't make synchronous calls to remote services, especially if the processing can take a long time. So you start bringing some queuing into the picture. So these days people use Kafka or RabbitMQ or whatever technology you're used to, but you kind of end up with the queues in the middle of all this process. I don't know. I've personally seen some variation of this architecture probably 1,000 times already in my life. I've seen it Amazon, I've seen it Google, I've seen it Uber, and much of users of systems which I talk to like all the time. And it's something which people just create like organically all the time. And it's never like, oh, let's design this thing. It's usually just grows organically. Oh, we do that, and we fix this error, and we do that. And I know we talk about things like monitoring, troubleshooting, operations. These type of systems organically grow is very, very hard to operate. Many people just don't think that they're stuck. They practically cannot change code. Because think about it, we wanted to do it just for 2 lines of code. And we end up creating all this machinery around it just because we want reliability, we want to make sure that we can scale. The other approach, like way to describe that is actually using fruits and vegetables. I kind of took it from my keynote from our last conference. And the way it is just, these fruits represent like business logic application, like strawberry. Then you have failure recovery and handling and like, and it's usually much larger than your strawberry because this part of code is much larger than your business logic. And then you need to do persistence. So you manage the state all the time, talking database queries and reading database, calling database, and so on. And then you take and put all these vegetables and fruits in the blender. And you like just blend them. And then this is your application. Because all these things are together. Like you cannot really separate them out because it forces architecture of your system certain way. And you cannot just go and say, oh, yeah, you'll have business logic here and you'll have failure handling and recovery here, because you already programmed the state machine, you already have a bunch of callbacks, you already need to deal with all these edge cases. And I call it smoothie application protection. Because this is probably what we are programming. We are practically creating this smoothie. And other interesting thing is that think about it. What if your customer comes to you and says, you know what, I hate strawberry, I actually want a banana. So good luck taking your smoothie, probably while blender is still going, and like fix that or separate it out. And this is what we see people doing, and that's why they get stuck with real applications, because it's almost impossible while in production, go and update your code and figure out how to fix your business logic. Because this business logic is spread out in 1,000 places over your kind of application. So how do we solve that? So you don't want to smooth it, you want to layer architecture. And we all learned in school, yeah, layers are nice, and it's clear, and we want to have our business logic in one place, we want to like error and recovery in another place, and resistance can be in another. And then if you want to change the banana, it's easy, you just change it in one place. It sounds cool, but how do we get there? How do we get from the smoothie to kind of cake architecture? And answer which I have is what we call durable execution. It's a new abstraction. This is something I never heard about. I invented this term practically, but let me explain what it is. Think about code, like whatever code you have in any programming language. Let's say here, I don't even know what language I use, it's some set of code. You have, let's say you have full bar and bus free calls. And imagine a situation, and we're talking abstract, we're not talking about any concrete platform or whatever, it's like new abstraction. And I have a physics degree, so I can try to think about like this abstract jobs instead of just a quick implementation. Imagine that there is a guarantee that this code will execute in the presence of anything. So just like there is some magic, and there is no like this code will guarantee like, okay, machines can go down, data centers can get out the edge, right? Like you can reboot the processes, everything will crash, you lose disks, but this code goes and executes. And it's very simple abstraction, right? It's pretty easy to grasp, right? Like, yeah, there is guarantee that code executes. What are the implications of that? So one is that you don't need database. I don't know, pictures messed up a little bit. You get these letters. You need a database. Why? Because as code guaranteed to execute, it means that all your local variables have to be durable all the time, right? Because if your disk crashes and you lost your variable, you cannot complete the execution. So practically, it already eliminates need to program against the database directly. You just can store state in your practically inside of your program, and this is guaranteed to execute. So it guarantees the durability of that state all the time. So other implication is that API calls, like practically any function call, can take any amount of time because we guarantee that it completes eventually. So maybe it completes in 3 months, but then it means that any iteration can take any amount of time. Can take 1 millisecond, but also can take 10 weeks. Because eventually we guarantee that it will execute. And why it's very interesting property, because you can use it for all sorts of interesting in all sorts of interesting ways. For example, one of these functions can be sleep. And if you have a business application, which I don't know, foo, let's say foo is confirm sign up of the user, sleep 10 days, and then send an email. And all you need to do is just say sleep 10 days. It's API call. It can take any amount of time. So you already kind of get this behavior, which if you don't have global executions, it's certainly much more involved. And if I try to do it any other way, you will have cron jobs, you will have global timers, you will have callbacks, you need to state in the database. Just kind of think about it, just one line of code. But obviously, if you have a global execution. So other property is that if you durable execution is an abstraction, very powerful abstraction, but it needs to communicate to non-external world, which is not perfect. And let's say there is some other service out there which is not using durable execution, it just has API, and you call it API, and when you call it, bad things can happen. So connections can go down, the service itself can crash, and so on. So how do we do this usually when we call an external API? We do retries. So we can do retries. And we can retry for a week, we can retry for a month, but the API for that function doesn't change because foo can block for a month. There is no problem, right? Because we guarantee this durable execution. And this kind of allows you to abstract out the error handling and retry logic. Sometimes you call services through queues, as I described initially. The same thing. This can this queues have nice properties like rate limiting, flow control, retries, and again, you can find it hide it 100% besides the same API, which is full. And practically, my point is that you can have very complex error handling logic and recovery logic and whatever, but as a programmer, you don't see that. You just call full, and some system can deal with that 100% hiding from the developer all this complexity. So as a developer abstraction, this durable execution is very powerful. So just to kind of recap that, durable execution is a way to keep business logic clean from failure recovery concerns, right? Your process can crash. You don't see that because it will be it's still durable. It should continue executing somewhere else. How? We can talk about it. It provides seamless resistance because you need to talk to database because all state of your durable execution is always preserved. And durable execution, I believe, is the best developer experience with resilient systems, distributed systems. So going back to our example, account withdrawal. Imagine that this is durable execution. And this is exactly what Temporal is. But Temporal is a platform which allows your code to complete execution in the presence of any failure. And again, complete execution is a little bit maybe misnomer because you can have loop, which will loop almost forever there. So maybe durable execution, especially as abstraction, can never complete. It can be always there. But there is guarantee that it will preserve its state and continue executing, right? Doesn't mean it completes. But if it doesn't have loops, infinite loops, it will eventually complete. And Temporal is a system which allows you to write code in your programming language. And we support multiple SDKs, and we'll support more. Right now, we support Go, Java, PHP, Python is in beta, and TypeScript. And we're planning to add .NET, and there is also Ruby client under development. So practically almost, and I think somebody just yesterday posted Scala, not Scala, some of these more exotic languages, but practically you can, but it's top level normal programming language. And this example probably is in Java. And you can write that and really guarantee. How it happens is that you make a withdrawal, and then your code is on deposit, and then your process crashes. So what Temporal will do, it will go and recover that process on a different machine seamlessly in exactly the same state. So all your local variables, all your threads, everything will be recovered in exactly the same state. And practically, when as a programmer, you don't need to deal with that because it just kind of migrates this process dynamically to another machine, and your code just doesn't need to deal with this thing. So practically, it provides this durable execution abstraction, but it's concrete implementation. This is what Temporal is. I can see in the future having different systems which are doing that, but Temporal is probably the main like open source project which is doing that. There are very just to give you some examples. The other notable one is obviously simple workflow was based on the same idea, which I mentioned. I worked on, and then co-founder of Temporal, Samar, who worked with me on the simple workflow, later went to Microsoft, and Microsoft at that he wrote Azure Durable Task Framework, which later was adopted by Azure Durable Functions, and now Microsoft has Azure Durable Functions product, which is kind of similar idea. But it kind of all seeded from the same source of simple workflow team. So just to recap that, the Temporal practically what it does with the abstraction of durable execution, it allows to hide a lot of complexity of those distributed systems. So practically internally, this kind of one of the other code came to mention here.
I have a question.
Absolutely.
So, so let's imagine it's like the deposit function. Yeah. So let's say we have a deposit function, and some of these functions, you know, they are not idempotent in external systems, and the system crashes right when you call this function. You might not even have the state saved of that exact call. How do you deal with that? And then the external system, if you call it again, it's work.
Answer is that if other system uses durable execution, it cannot crash. If external system which doesn't use durable execution and has non-idempotent API, you need to fire the guy for overloading, right? Longer answer is that you have two options. One, fix the API, make that important, or you can practically say don't retry and get error back, and error back can be timeout, and you are in state which you don't know, and then you can run different compensation functions. Practically, the only it's just a property of distributed systems. If you got timeout back, like even if you're talking just a normal database, you will have exactly. Then you can run compensations. Practically, in this case, in Temporal, you, as I said, you either disable retries and run compensations, or you use retries, and there is no magic there. Yes.
So event sourcing also says last not least, you have to have compensation functionality.
Yeah. Again, it's not. It doesn't matter which technology you use. If you use Temporal, not use Temporal, like it's just property of any distributed system. If you go timeout back, you are not in the state which you don't know it. Like you don't know your state.
But how do you know, make sure that you know, when the system crashes, just before you store your durable state, how does that work?
Okay, so that is a different story, because system, if you think about it, From durable execution by itself is a nice abstraction, but is any piece of code, if it doesn't create any side effects, right? You don't know, it's not very useful, right? Like any practical use of durable execution is always store some external system or some system which will produce some side effects. Side effect can be, I don't know, some output in the screen, or side effect can be put in some service or changing some file or whatever. But those side effects can be programmed to be either important. But that's why we can recover practically. If it's not safe, you'll kind of execute that and get to the same state. And if it doesn't have side effects, you won't notice that. As a programmer, you need to do is that kind of have seamless. So all you need to code here is that your side effects are identical.
Are you saying that when you're calling, like what he's saying, his example, you don't store the durable state, then you don't know what really happens, right? And when you're writing this workflow, shall I say, you need to have a compensating function anyway for the deposit always to check if.
Only if it's not that important.
Yeah,
And my understanding is like no, any reasonably guess.
yeah, that's fine. But let's say something happens in the deposit call and it never reaches the API.
Then it will time out and do the reply. I guess in temporal world, every API call by definition has time out to reply. And you also say, I do deposit, I wait 5 seconds. If it whatever, I will retry it. And retries can be, you can keep retrying for the week if necessary.
How do we catch error in temporal?
In temporal is I can show you.
It happens in temporal. So
You don't, because it automatically will recover. So as a programmer, you need to deal with that. It's practically there are timeouts as well. Practically, what will happen is that it will detect the crash of the process for timeout and recover that state in a different process automatically. So the main point is that when you write code, like and between durable execution in temporal for legacy is we call workflow. We call workflow an activity used with that terminology. So workflow state is recovered kind of mathematically. And when you program, you don't think about failures of the processes to maintain workflow state. And it's always doable. So you don't need to go to databases to for this stuff. Any more questions about that? I think it's important to understand the concept. Okay. So going back to the this idea is that internally, sorry, I came back to this actually to show one thing. In temporal, what we like this square is which is written temporal is a backend cluster, right? You can think it as a database process or whatever, right? Or Kafka cluster. And the temporal cluster doesn't run the code. It doesn't run like the code of the workflow. It doesn't run the code of activity, right? So these are external processes. So practically, if you write an application using temporal, you will write code of your durable execution workflow. You will write your code of your activities, and you will run them yourself. All you need to do is connection to the backend temporal cluster, and they're both open source, so you can run, and you can multiple applications connecting to the same backend cluster. And this code is just normal code. It's like you use SDK, you just input that into your service practically as a library, and you configure it to connect to that endpoint. And this is it. And it's part of your deployment. You don't need to deploy this code anyway. Just you deploy it to your normal way you deploy it. Right. So if you're using Kubernetes, it will probably just bunch of pods and running Kubernetes with your what we call water processes, because this. And also the communication of also steps temporal plus gRPC interface. And when for example, you need to execute activity, your what we call worker process will not doesn't need to open ports or anything. It just will go call to the temporal server to get tasks, with an activity task, and it will go and say, okay, I'm listening on this queue, what we call task queue. Give me task, gets the task, executes that, and reports back to the server. It's completed. If it doesn't report on timeout, it will time out and will be retried. But the more important thing is that to understand the topology. There is service, and service is complicated, it has a lot of components. And then there are processes which implement application logic, which you run, and it's part of, and they can be different languages. I said we have multiple SDKs. So one activity can be in PHP, another service can be in TypeScript. and then it can call what we call child workflow and Go, and so on and so on. So you have polyglot example. There are like 5 languages in one single application. And as I want to say is that Temporal hides practically a lot of complexity to build distributed systems from you. So internally, the cluster, if you look at that, it has all these concepts. It has route, sharding, consensus, load balancing, queuing, global timers, and so on and so on. But it's all kind of hidden from you. You just write this normal application business logic code, and then this service deals with distributing that, moving to different machines, like recovery state, and so on. You just focus on your business logic. It eliminates 80% of your code in a lot of cases, because you don't need to practically use any frame, use any kind of additional things like, because right now how we do that, as I showed initially, or we have queues, we have database, we kind of compose all of that together, and then we kind of try to create that using this low-level abstraction. Temporal abstracts that all out. You don't need to do that explicitly. And the best part is open source. It's an MIT license, so you can use that anytime. And there are a lot of companies running that. I don't have slide, but I can probably just open our website. Just notable companies using that in production is like Snapchat stories, for example. When you update the story, it is a workflow, right? Then HashiCorp. Like we are talking about infrastructure, HashiCorp, all their cloud offering is built around these workflows. So they run Terraform as an activity, but they still need to kind of high reliability for long running processes, and all this infrastructure automation is implemented as a bunch of workflows. Then Banzai Cloud, and I don't know if you've heard about that. These guys were doing practically Kubernetes cluster management and deployments in different regions. All of that was it's actually open source, so you can find those workflows online. They were doing that. DataDog, all the infrastructure is practically managed as a bunch of workflows. DataDog is a very good user of Temporal. And then there are business level. For example, this was built at Uber. At Uber, things like Uber Eats, payment systems, and so on and so on. There are a lot of those systems which are workflows. And then obviously infrastructure automation, like rebooting, for example, upgrading kernel in the data center. There are like, I don't know how many tens of thousands of machines. How they guarantee that every machine finally gets, you need to shut it down, like deploy kernel, right? Like reboot it, check if it's in its health, go to the next machine. It's obviously a workflow. So there are a lot of usages there, like provisioning data centers, provisioning availability zones in AWS, and so on. There is very long list of. If you go to our website temporal.io and find the case studies, you will find a lot of case studies there. So I give it money transfer. Now I want to kind of go a bit, spend a little bit more time on infrastructure provisioning. Why this is used? This abstraction is useful. One thing is that people usually don't. That's why I don't like this workflow name, right? Like for example, Google execution, I think is much more representative, because when I say workflow and then I go, you know what, you want to manage your Kubernetes clusters, right? You want to like worldwide distribution of Kubernetes clusters, so you have like dozens of them, and you want to use workflow engine. Most people will think I'm like nuts, right? Because people don't even associate workflow engine with this type of applications. And Temporal is actually very, very good fit for that. Because why? Because infrastructure fails all the time, right? You want to guarantee that things happen. And logic can be very complex and dynamic. For example, you need one activity which gives you like a bunch of IP addresses, and you want to execute activity per address. You need to route activities to specific hosts, which Temporal supports. And there are a lot of kind of usages for that. Other thing which is people don't even associate with workflows is lifecycle management, because durable execution workflow can be long-lived. It can be always lived. You can, for example, if you have Kubernetes cluster, you can have workflow for that Kubernetes cluster which is always running and just listens to events and reacts to them. You can have, it's more like state machine, right? But all its state preserved in local variables. There is durability there. It can execute actions durably. It is retries and everything. So there is very common pattern to kind of have life cycle management of any resource. Other usage for that is IoT. For example, if you have IoT device, you have digital twin workflow for the device which is always running and manages, for example, upgrade cycles and all others for that workflow. So always running, we call them entity workflows. A very, very powerful abstraction. And I will give you some thought sample which how it would look like. But I think it's temporal is not only just executing sequential things with any complex logic, but it also can be just always. It's more like other way to look at this, like durable actor, right? Like people know about actors, but it's something which is durable and not linked to a specific machine. And the other DataDog is here in this slide. I cut and paste it. But it's also CI/CD, for example, Netflix neckar. Netflix guys are rewriting neckar on top of Temporal right now, like at least inside of Netflix. And then managed services, for example, RDS, like AWS RDS service. Like if you need to build service like that yourself, a lot of companies are building these offerings using Temporal as a practically the control thing for this type of services. Obviously, we have I think Netflix has one project to manage RHEIN clusters, kind of automatically. And yeah, Kubernetes provisioning, I already mentioned.
Maybe one more question. I guess the answer. One more question. So I guess the answer is probably recursive. So how do you compare durable functions with what Kubernetes is actually doing? You basically state a declarative desired state, and then you've got the controller which always tries to get that state done. And of course, you can use probably temporal inside the controller to do the micro transaction. But how would you place temporal on the outside of the macro level? Just
actually, engineers from our team, I think presented last week on together with I think other company Chronosphere, which they made good metrics, and they exactly had this talk how like this compares. I'm not like super expert there, but I have very limited understanding of how operators work. But if you think about operator is like exactly what you described initially. It's a state machine, right? You have this loop and you call it every time and restate there, and it works. But this state machine usually, at least talking to people, it works for simple things. So if you want to like, okay, I want to like 5 ports, 1 port goes down, like I want to like start another one. But then if you say, oh, I want to like do backup of my database, which is like relatively long run operation, which can fail, which has multiple states, right? Which you need to execute things. Programming that state machine becomes practically possible. We always can program state machine, right? It's just that again, 5 lines of code, like do that, do that, do that, and like in this timeout of 2 hours, for example, for certain operation, become like this practically quagmire of callbacks. So it's possible to program that, but we found that a lot of people prefer to write workflows using temporal abstractions than programming operators directly. So technically, one of the ideas I had, just never was something I cared about, is to practically write operator framework directly by means of temporal. I think it's possible. It's just nobody can. For example, our team for our own like cloud offering, we obviously just bunch of workflows and we use Kubernetes. But our team decided one of the operators, they just program everything in just bunch of workflows, and it's much simpler. Other thing is that every time you do multi-cluster, I know some people do crazy things, like they have special cluster with operators which orchestrate clusters, but this model doesn't work very well. Every time multi-cluster workflows are just bunch of abstraction for that. To kind of, when you need to provision, and especially if there is other part, there's like recursive thing. You need provision the cluster, you need to upgrade the cluster, you need to do something like more complex or migrate some processes to another cluster, deployments, like complex deployments. These things are much easier to do as workflows than as operator. But I would take it with a grain of salt. I'm not expert on writing operators, but I've heard they're extremely hard to write. And especially reliably, especially in edge cases. And workflows usually get feedback that they're much higher level abstraction and a lot of things just.
Right now, for example, they are writing and the same operator, they are writing when they operator thing, there are things not very difficult to write operator. So how do you then comment on these things? I mean, writing an operator takes, I mean, initializing the whole skeleton takes 5 minutes, really. And then you have to specify some things, maybe 10 minutes, 5 minutes. And these operator frameworks, I can name some of them, like operator SDK, to build any of them. And it's not difficult anymore to write your desired state and your current state and what you actually want and how many pods you want, how do you want to scale them up, and like for example, how to auto scale, like you said, like it really depends on how much load you're getting. And then you can also define auto scaling techniques and everything. It's just writing a simple YAML file.
So okay, this goes to a completely different high level discussion very much. Practically, when I talk about temporal, we didn't ask that yet, but I'm pretty sure somebody will come and say, okay, how do we compare like JSON workflows, features, features, and so on, right? And like which people call DSLs, right? And I personally think DSL is actually misnomer, right? Because DSL by definition is domain specific language, right? And domain is important. So I personally love domain specific languages. But what you describe is domain specific language, right? So you say there is a specific domain, and for pretty specific subset of situations, right? We have this language which will be presented in JSON, and you can write that. And I think it's awesome if you can simplify your problem to the point when you can write JSON file, and it solves that. Awesome. Problem is like people come to me and say, oh, how do you compare like step functions, for example, right? And step functions, they call it DSL. It's not DSL because what's domain specific about step functions? Besides the random events, right? Like there is nothing domain specific. They're just general purpose programming language in JSON. And you tell me, do you want to program like general program process in JSON versus like in Java? And what about like a refactoring? What about unit testing framework? What about debugger? What about like type, like practically like the whole power of language becomes like mess, right? Because you practice. But as soon as you say, no, I have a very specific use case and it's like it's narrow. Config files are awesome, right? And but it should be domain specific. I think people miss part of domain specific when it's called DSL, like something like general programming framework in what we call workflow. But temporal, if you think about it, it's code, and in code you can write anything, including interpreter for any domain specific language. So temporal is actually one of the very common uses of temporal is writing domain specific, use it as engine for domain specific language. Because if you think about it, people who create domain specific languages, they are experts in their domain. They're experts how to kind of define that and think about it. These people are very rarely experts in how to write large scale distributed system, which will execute these things like 100,000 times per second, right? And reliably and with guarantees and durable time and stuff. And temporal is that engine can run that, provide that. So it's very common that people do that and write the domain specific language, write interpreter as a workflow, and then get all the benefits of temporal, but they get the domain specific language. It also depends who your target audience is. For example, obviously, the infrastructure framework, everybody's about DevOps, engineering, and so on. But imagine you're building an application for your customers. Obviously, you're not going to give them Java or JavaScript. You're going to give them some UI, you configure some steps and whatever. That is all very example. But then you generate JSON from that and you use temporal to interpret that. Very common example. Like we have many customers doing that. Oops. I can mention that already, just to reiterate that there is temporal cluster, and I have the whole presentation you can find online on our website about why it's structured this way. But basic idea, there are multiple roles. You can scale them. So far, we couldn't find a database which we couldn't saturate with this solution. So practically, if you have a database, including like 100 node Cassandras and larger, much larger clusters, we can saturate 100% of that just with this architecture. So it's always bottleneck as a database. And in Vera front ends, they export gRPC interface, and then your application is workflows and activities. They're external, as I said, and you just use library like which they link, and this library for gRPC interface talks to this front ends. So I just want to show you like some practical how it looks in real life, just some code. And bear with me, it's not something which I rehearsed a lot, but I think it can just give you an idea what the experience looks like. We have many SDKs, but as your Kubernetes group, I've chosen Go just to show you how it works. But again, we could do that in Java or TypeScript and so on. So I prepared some activities. So in this case, it's just run instance, which just all it does is just calls the standard run instance AWS API to start an instance. And so if you want to call it from the workflow, probably what you will do, you will just it's kind of funny how we do it in Go. You create new reference. And we just call execute activity passing this new reference because it just all takes name from that. It just takes run instance name, activity name, and then pass arguments which we define here. So we had two arguments, obviously image ID and instance type. And when we invoke that, we pass image ID and instance type. And then we get a future back. And in this case, we just call get on this future immediately because we want a synchronous block. And this get will block. And it will populate the instance ID which that activity returns. Then we do standard fancy Go error handling, and this is it, right? Let's try to run that. Another important thing is that in the context we insert activity options, and there is one very important option is start to close timeout right at the time of single retry, right? You start activity, and we say it cannot last longer than 10 seconds. If it 10 seconds, it will be retried. And every activity by default has a retry policy, like infinite retry policy. It's exponential. In this case, because it's a demo, I disabled practically I set maximum retry interval is 10 seconds, so it will not retry longer than every 10 seconds. It will start from 1, I think exponentially grow up to 10 seconds. But this retry policy is like normal exponential retry policy, like has 5 parameters like coefficient, you know what, it's the deal. So let's run that. Let me see. I did the presentation mode, that's why I'm lost. Okay. So this process, as I said, there are two types of process. One process which hosts code, right? We call it worker process. It doesn't. We start this process. It's like a Kafka listen, right? It listens to messages, but you need a message to process something, right? It's like a few consumer. So this process just has workflow code and activity code, but we still need to start some process with some ID, practically like workflow, right? ID. So let's start one. And oops, it's the wrong one. So we started workflow, and this is this ID, and we see that something going on. But how do we troubleshoot that? So Temporal provides a lot of kind of visibility to what's going on. So let's look at the UI, Temporal UI. So we see auto scaling group of flow ID running right now. So let's look at that. And first thing we see that there is pending activity. Let me make it larger. Yeah, guys, come closer. Make it larger. But first thing we see that okay, there is error. Invalid parameter value, right? Minimum. Okay, so we have our activity failing, and oops. And we see that it was it's failing, but it was already tried 10 times, and activity type is run instance. Other thing we can do, we can go and check the stack trace of the workflow, and we will find out that it's blocked on the workflow line 21. We can go back to the code and find line 21, and we see that we blocked on this line because we invoke this activity, workflow is blocked on this activity, but this is durable execution, right? It just hits there. Just to prove that it's durable, I can go and kill this worker process. And then I can start it again. And we can go back and kind of refresh this. Probably this request was lost. Oh, it's actually refreshed. And we can see that it's still blocked on this line of code, right? And this activity is still I'm just not used to such a large zoom. So we see it's already 16 every 10 seconds it retries. Why it does that? What in reality is that I just put bug there.
Quickly,
Huh?
just a stupid question, but you started two processes. I didn't understand why.
Oh, okay. I didn't clean up the thing. The reality is temporal guarantees uniqueness by ID. But you see one of these processes not running. It was terminated. I killed it. This is like, and if you look, it was like a couple hours ago when I was preparing for the presentation.
No, that's not what I meant. When you started the example, you started the work.
Oh, two processes. Yes,
Yeah.
one process that is important. One process is worker code, which contains code. It's like listening, queue listening. Another process is actually called start workflow. It practically starts the actual workflow with this ID. And in real application, what will happen is if you write temporal, you will have worker processes, which are practically sit there and have activity in workflow code. And then you will have other processes, for example, your front end, getting request and then calling start workflow or
Okay.
start.
So the first code with the workflow, which you show with run instance, where the
No, but
workflow dot execute activity just registered and was waiting
Yes,
until.
until I started the workflow.
Okay, got it.
Yes, and that is the second process exits immediately. You just started that instance and exit, right? Other thing is because it's running, if I call it again, it will just reconnect to that instance because it's the same ID. I hard-coded ID.
Okay.
Usually it's business level ID, it's like order ID or customer ID or whatever, right? So in this case, auto scaling group ID, right? Group one is an ID. And other thing is when you start, you also can specify what we call ID reuse policy. You can say, don't allow starting new workflow, even the previous one failed or completed. And by default, it's allowed duplicate. So if it's completed, it can start new one. If it's running, you never can start new one. But if it's complete, you can choose. There is like a policy, there are like 4 policies. One is terminate and start, so it will terminate previous and start new one. Then there is policy allow duplicate, so it will start if previous completed. Then it will allow duplicate if failed only. So if it failed, it will start new one. If it's completed successfully, it will not start new one, right? And then there is one which prohibits, you cannot start new one at all, it will fail. Return you like duplicated. So we have like full control over that. So the reason is why it's failing is just because I on purpose put bug in the activity implementation, I specified min count of -1. One thing I want to demonstrate to you is that what is intermittent failure? In this case, we can fix the bug and redeploy our activity code. In this case, I just restart the process, obviously, but in real life, you can do real deployment. And then we can go and check our workflow state. It's probably waiting 10 seconds for the next retry. Oh, you see it's already completed. And we have a workflow execution history, which is like very important troubleshooting thing, because we see, oh, this workflow auto-scaling was started, and we see a lot of parameters here. And again, this is big zoom, so it's not easy, but we see when this event happened. We see the identity of process which started this workflow, right? So this exactly run this separate process which failed, right? Then we see the like queue name it uses to deliver tasks to this worker, and then input of the workflow result. Because oh, sorry, I'm looking at the wrong event. This I'm surprised. Yeah, this is like one event. Then we can see a lot of information about this workflow timeouts and so on and so on. But then important thing is that when we run this activity, we can see, okay, this activity was started, but there were 31 attempts of that activity, and this is the last failure before it succeeded, right? And also we see the identity of the process which was running this activity, and so on and so on. And then we see completion of the activity and result of it. So everything is recorded. It uses event sourcing internally. Every event is there, but it's very easy to troubleshoot. So okay, activity, and then workflow completes because there is not much there, right? And this is a result of the workflow. In this case, I think it doesn't return anything. That's why it's empty, but we know it's completed. So one important point is that, think about it, this workflow was running, activity was failing. It can fail as long as necessary because it tries infinite. And then I fixed the code, deployed new code, and workflow completed. So was it intermittent failure or not intermittent failure? So practically, if you have workflows, intermittent failure can be half a day until we fix the bug and deploy new deployment. And your workflow doesn't fail, just keeps going. And very frequently people say, oh, how do I deal with outage? Very frequently you don't need to deal with the outage at all. All you need to do is just redeploy your code and fix that, and it continues executing. And this is the kind of power, this durable execution idea, that your code, you don't need to do anything with your code when you fix things in production. So let's make this example a little bit more interesting. And okay, this actually did run, did real instance.
One question. If I just imagine this case where somebody or where a user uses my web app and the backend system has an outage, and it does, so the customer does certain actions and it gets a failure, right? It gets an error that it did not work after some time. Let's say we want to send our shopping bag to the backend system, and it's just waiting there. There's a good chance that he just opens another browser and just does it again.
But that's why you use the same ID for your shopping cart. It will connect to the same workflow. Query that workflow and get the current state of the workflow. It's unique.
So then I have to read, but then I have to read every time if there is already a process in a similar way.
It depends.
If there is an order already, do you really want to do it again?
No, okay. If you're just starting that, again, as I said, it can be viewed, but you use automatically, right? You will just connect the same thing. If you're showing shopping cart, I assume that you will show it. You need to query for the current state, right? There's actually even somebody not even from Temporal wrote a series of blog posts how to implement shopping cart onto Temporal. And it kind of becomes kind of silly because you just use Temporal for persistence, right? You just have shopping carts as arguments in your as a local variables in your workflow. But when he asks question, okay, now you need to implement the feature that abandoned shopping cart, right? Like you have shopping cart, you didn't come back for 5 days. I want to send you email, right? Maybe you're like, you have some. And then in workflow, he just puts a timer there, sleep there for 5 days, and sends this email. And they say, okay, if you don't have workflow, I added 5 lines of code. How would you implement that? Like if you had like normal database with shopping cart, and then you probably need to start engaging these new systems. Then so workflows make these things much easier. And I'm not saying like you always need to build shopping carts for Temporal, but it's actually very common.
I understand it, but I think for very much every user interaction in the browser, for example, it is unusual that basically certain actions are blocked in a form, most likely, right?
So there are two parts. If Temporal itself is down, it's like, okay, so it's like the base being down. If Temporal is up and running, and some activity is running, we overflow. Oh, okay, there is one important part. Workflows are asynchronous and multi-threaded. So if you are listening for some action, you can listen for this action asynchronously and execute this activity asynchronously. If you want to say, yeah, there is activity is running, I want to react to user. You'll probably run this activity, as I said, it returns future, right? So standard thing in the Go, I can actually show you some code, but basic idea is that how you would do that. You will listen on the external event channel. We have like we call a signal channel, and you will listen on the activity future, and you also probably will listen on the timer in the selector, right? And then you will just whatever happens first will unblock you and will do some action. And it's a pretty standard workflow code. So you can absolutely do multiple, or you can create another Go routine and do something in another Go routine while you are waiting on this activity. So workflows are like real Go programs. They are not like sequence. Don't think it as I'm creating some dev behind the scenes. I'm actually executing real Go code. There is no like creation of intermediate steps. Like if you ever seen something like Airflow, right? You're not creating that. You're not creating any intermediate like a F-stack syntax tree. It's not. It doesn't have DSL. It's just really executing this Go code. You can put in a step in debugger through that, and it's just Go code executed.
Can I ask something?
I forgot about microphones. too late probably.
Yeah. So my understanding of Temporal is that very simplified. It's Kafka with a bunch of other features, because you have on one end you have somebody sending something on the bus. In this case, it's like you write an application that's going to call Temporal and trigger something, and Temporal is responsible for running this task somewhere. Is that what it is? And that essentially is my application that I wrote.
It's I understand what you mean. To replicate something like Temporal.
I don't.
No. All I'm saying from functionality point of view,
Yeah.
all I'm saying is Kafka is just delivers task to the worker, right? But what about like just most basic thing? I created this task, and I want to say this task didn't complete in one day. I want to, for example, do something, right? How do you do this stuff? You cannot, right? You need to have a database or timer service, and you need to have some state. And then, or you get event while, or you want to cancel that thing while it's waiting, right? Like there are, it's not just delivering messages. It has internal queues, kind of similar. It's not like Kafka, because Kafka is not a queue, right? So I can have a long discussion about why Kafka is not a queue, right? But it's a better than queue. It's not queue. It's a good abstraction. Kafka is useful. But what I'm saying is that it's not about that. It's about state management. It's about timeouts. It's about guarantees that your state is preserved, right? It's about like tying all this together. Queues are just small part of that. And then I don't have. I can. There is presentation I will give you a link about this. That I think I called this building a workflow engine from first principles. I gave it on the Facebook invited me to be there. I think at scale conference, and I gave the presentation explaining kind of what it takes to actually do that. And there is other part, transactions. For example, if you even start building that yourself, let's say I use queues and a database, all good, but then you need to have transactions between queues and databases. And yeah, you need to start doing a box pattern. You still, or if you don't do that, you will have race conditions, because I put stuff in the queue, then I need to the database, and then my secondary.
I'm not trying to make you tell me why Temporal is much more than Kafka. I'm just trying to understand, like fill the gaps that I didn't understand from your presentation. You know.
No. Then probably I listened to your question, because I thought you said that Kafka can achieve the same.
No.
So then like can you explain what's it again? I probably missed that.
I'm trying to understand, like, so Temporal is like something in the middle. Let's call it this way. And I send instructions, sort of a lead guide instruction to it to execute a task. Is that correct?
Well, Temporal is you have a code. You have code.
Right.
And this code can receive external events, but it doesn't need to. For example, if your code, the code I showed here, right? All it does is just executes one action, right? One task.
Right.
So this code doesn't receive any instructions. All you receives is start this code, right? These parameters. It's like start this function. And then this function executes, and we guarantee this function completes.
Trigger.
A trigger is it's an external any API call, and in this case was second process. So practically, let me show the trigger. That is actually a good point. I'm trying to kind of simplify things, but if you look at this starter process, practically what it does, it gets connection to the gets client, Temporal client, and then it calls client execute workflow, and it passes options. In this case, as you saw, ID, auto-scaling group ID. This is ID of the workflow. Task queue, this is queue used to deliver tasks to the worker. And then this is the workflow name, right? And this workflow name is exactly the workflow we're talking about. So this is a separate process. This is the whole code of that process, right? All it does is creates a client to Temporal and calls execute workflow. And this is practically the starter. And this can be in any language. It can be just direct gRPC call. Again, it's usually part of your front ends or separate services or whoever needs to communicate to start those workflows. Does it answer the question?
Yeah,
Okay, so sorry, I'm slowly understanding.
I think my understanding was right. Maybe I didn't bring my question correctly.
Yeah, no problem. Okay, so going back to the workflow, let's make it a little bit more interesting. So, as I said, it actually did create the instance, right? We probably at this point we want to kill it. Oops. Thank you. Insecure. Okay, we'll terminate that. But let's say I want to something like autoscale. Let's say I want a situation that simple thing. I want to my workflow wait until instance starts, right? Because I call start instance, maybe it never starts, or maybe it takes a long time, or maybe it's imaginary. Imagine I can have a workflow which will wait for spot instance, right, to start or something like that, like long time. But let's say that an activity which waits for workflow to start. And I have this some prepared code here, but basically, you want to see me type too much. No. Okay, that was long. But okay, so practically we had code which was calling run instance. I added new activity which says await instance state practically, and I want to wait until instance is running state. And as this activity can be very long running, I specified the timeout of 10 hours. But at the same time, I specify heartbeat timeout because if activity is long running, you don't want to wait 10 hours. If it worker process fails, you want timeout faster. That's why activity should heartbeat. In this case, I specify 10-second timeout. So it at least once in 10 seconds it has to heartbeat. And I also specify this retry policy every 10 seconds just to make sure that it doesn't retry like for too long. And I create different context and I call this activity. Let's just run that, and then I will show you how this activity is implemented just to make it a little bit. So let me redeploy the worker, and let's start new workflow running the starter process, and let's watch the workflow. So this is new one running, and pending activity is await instance state, and it didn't fail, right? So there are no failures, it's just first attempt, and we can see that it's waiting this activity, it's reverse order, and all good. Let's see when this workflow completes. Okay, it's completed. So we can double check. It activity await with state started and completed. It started 20:15. It took like another 15 seconds for instance to start. They start pretty fast these days, right? And at the end, workflow just completed, right? And we also see that when it's completed, returning the state. In this case, state was actually didn't return anything wrong. But when it was scheduled, we see the instance ID passed as a parameter, and we are waiting for running state. And just to let me show you the await instance state activity. It's pretty straightforward. It just calls describe instance state, which is in this case calls describe instance status API, and just returns the state name of the state of that this API. And if there are no statuses, practically doesn't find anything. It just returns not found. Right. So that is pretty simple function. And then what we do here in the activity implementation, we call this, and then if it's desired state, we just say we return. If it's not desired state, we return heartbeat and wait 2 seconds. So we practically poll activity for 2 seconds. So it's a very common pattern in Temporal. If you need to poll for something, some resource very, very frequently, you're not going to do it from workflow, just do activity polling and heartbeating back. But again, there are no limits how long activity can do that. There are applications that people do it for like 4 months. And then if this worker crashes, activity will get retried on a different machine, like in 10 seconds, because heartbeat timeout is 10 seconds. So it's kind of very common pattern, like watching files, watching a file on S3, or like practically any API call that you need to call. You know, like there are a lot of shitty REST APIs which require polling. And this is very common, like people polling REST APIs for every individual request.
So, but how would you this pattern that you just executed that workflow in one process? Can you execute that process again on another machine or on your machine twice, and you actually do leadership election and only one of them runs through? Or how do you?
So first workflow I execute on one process, but it's not linked to this process. I already showed you killing the process in the middle. It's like another process. In real life, you never run one process, you run full of processes. Yes. And any of this process having an issue, workflow will migrate. Right. Also, if workflow is passive, waiting for something, for example, it waits for its activity, workflow is not doing anything, it's just waiting activity. So it will eventually get out of cache of that machine, or even if you bounce that, it won't be in cache of that machine. It just sits on the server. So only when activity completes or other event comes, workflow needs to make next steps. Then it will be resurrected on the worker and continue executing. So you can have millions of waiting workflows.
So there's some boilerplate at the beginning where your central system automatically executes another, resurrects that process somewhere else.
So it doesn't resurrect the process. No, you mean by process, you mean workflow instance, that right?
Yeah, that's
workflow. Singular. Durable execution is not by definition workflow instance. Is not linked to any machine, right? It lives in this kind of pool of your machines, right? So you can. When you program, you don't think about resurrecting or not resurrecting. When you try to understand how it works, obviously the engineer wants to understand how it works behind the scenes. Yes, it is resurrected on your worker, but then the next moment it can be resurrected on another worker if necessary, right? If something crashes or whatever. But when you write code, you don't even think about this. All you think is my process runs here, and it has this ID, and it's unique by this ID. Activities on the other side, you care when they run, right? Like location of activities. So we have means to run activity on a specific machine, and we don't have time to go there. Practically, if you have the specific machine, for example, very common scenario, I have workflow, a process file, download file from S3, transcode to different bitrate, upload that. First activity can run like you have pool of machines. First activity can run on any machine, but second activity should run on the same machine because file is there, right? Third activity should run on the same machine because file is there. So we have means to route activities to the same machine because activities do have locality. Workflows don't. They're kind of nebulous.
I think I misused the process in you have a different note. I meant that Go process.
Yeah, Go process. Workflow is not linked to a Go process.
So I can have 2 Go processes with that same code, and with your temporal workflow engine, you basically do the workflow here continues, and that other one just is a standby and waits. Can you?
In reality, you have in any real application, probably don't have one workflow. You have like 10 million of them, and it means that like they always bounce in there, and like it's probably there is a cache of them. As soon as it gets a lot of cache, next time it needs to make processes, you'll find new node and so on. And we manage that. We don't need to care about that. From your point of view, just deploy pool of machines. If you have enough capacity, good things happen.
So for me, while I listen to this, the more you talk about durable execution, the more it sounds to me like it's eventual consistency. What do you think is the difference between eventual consistency and actual parroting versus durable execution?
So durable execution itself is not eventually consistent. It is fully consistent. For example, it's fully transaction. For example, if you invoke an activity, in real life, it will put there is what we call task queue inside of temporal service. It will put task to invoke activity into the task queue. And it will update state of the workflow itself because like we move to the next line, you update some variables, right? Like and so on. So this is transaction. We use our box pattern internally. So there is guarantee that if this activity is invoked, state is updated. If state is updated, activity will be invoked. At least task will be there, or it will eventually time out if something fails, right? But external vault is by definition eventually consistent to whatever. There is no like distributed transaction across like temporal workflow, like durable execution and some other services, like EC2, for example, right? I cannot do two-phase commit to EC2. So external vault is eventually consistent, but workflow state itself is fully consistent always. And also guarantee uniqueness by ID, things like that.
So it's basically the same as a Kubernetes resource if I would compare it, because the Kubernetes resource is also, of course, consistent.
Yeah, because it's like a
But
system.
any update to that, obviously,
Yeah.
you have to retry it and so on.
I'm not sure if Kubernetes resource is consistent when you try to put something for processing, because probably put it there and then can crash.
I guess it's kind of like figuring the workflow for you, right? As long as the update to the API resource is completed successfully, we guarantee that eventually the state is changed, right? And for you, it's the same. So you say you trigger the workflow, right? And you guarantee that eventually either the timeout happens, right? Or the state
Yes.
change that you
Yes.
want.
Correct. Yes. And again, activities can time out, but like workflow, usually you don't specify timeout. And again, you can, but usually you wanted this to complete and so on. Yes.
Exactly how Kubernetes controllers operate. They call it eventual. I think that's what you mean. Because
Yeah, it's eventual different the rest of the world.
like you have an endless loop that iterates and waits for the state to become whatever it's expected,
Yes.
and we repeat until successfully.
I think the big difference is that state is in the database, right? You always kind of load it from this key value store, right? Then you do something, then you store it there, you change. Like here, you just use local variables.
So what I also understood is that you store the state in the worker process, right? But while you translate, for example, a failing transaction from one worker to the next, right? Because I imagine you register maybe n workers for some worker pool, right? And you translate that state, where is it actually held? Is it in temporal? So how is that trained?
It's state is stored in the backend.
Okay.
Actually, state, okay, state is actually just these events which I showed you in the UI, right?
Right. So these
So all we do,
variables that
we
you
use event
pass
sourcing.
in the workflows, these you store in temporal. That's
So yes, so your workers are statements.
okay.
So practically just, you can add and remove them anytime, you can bounce them anytime, your workforce will continue executing.
Can I ask one more thing? So when you somehow register these functions to operators, you don't call it, right?
Yeah, I missed the practically there is a register function this worker.
Yeah, okay. And in order for this to execute, there needs to be a place to run it. And it needs to run this specific worker that you wrote, right?
Mhm.
You call it activity group, but I don't know. Sorry.
So yeah, activity
Yeah. So what, like, does the role bring up these?
We don't control your work. No. The code, the actual code, you run, you don't run.
So
It's
then
your
I need to run workers for every.
It's part of your service. It's like you run Kafka consumer, right? Like Kafka doesn't run your consumer. It's just your consumer of your producer, the same way.
Yeah, what I'm trying to understand is like, if I have like 10 different or 100 different activities like this that do something, I have to stand up like 100 different machines.
No, you can just on a single machine have like 10,000 activities.
And have them all connect to the.
No, it's just code. You just reach this code with this work. Okay, internally activities is patched to queue. So there is a queue, and then you start worker listens to a specific queue. And if you reach the 10,000 activities that worker, you can put message in that queue saying activity A, activity 2, activity 3. It will pull message to the worker, find appropriate function code. And it's all local process. There is no limitation how many activities can list on the same queue. We also have dynamic implementation. We practically can put anything and it will like just get, oh, it's a string activity name. Let me load this from remote source like activity implementation.
And I have a concrete example. If we're running Temporal in production at my company, and we just have a Go web server running, it's an HTTP server and requests, and our activities are just in there. and they just connect to Temporal, and Temporal runs the code on it. So like all of our activities are just in the same repo, it gets deployed in the same instance. And this is also where we have our handler running. Yeah.
So think about services. It's a deployment strategy. It's up to you, right? You can have one monolith, or you can break it in 5 processes, but it's not really related. You can absolutely have 10 services in one client, right? You can do it. It's the same thing here. It's your decision how many activities you want in one process. If you want all your application in one process and type process, you obviously want more instances for availability. You can do that, but if you want to say this activity is heavyweight, is uses GPU, I want to run it as a separate pool, and that activity uses a lot of memory, I want to run it here, but all other activities are there just calling some APIs, I want to run them in this process. You absolutely can have this approach.
Question from the perspective of an application developer. So if I understand it correctly, then I use the Temporal SDK. I no longer have to worry about technical errors of the API, retrying and exponential backup and so on. That they will all be handled for me. But some errors are like business errors. For example, in the banking example, if somehow the transaction was started with the wrong account, and the API that I called to make the deposit returns, hey, it's not actually a user. This account doesn't exist. Retries won't help. But now I have to disentangle the API error that Temporal maybe handles for me with the retry from my business logic. How do I specify, hey, Temporal only retry these kinds of errors, but don't retry those kinds of errors?
Yeah, that is very good point. So there are two ways to do that. One is that retry policy has non-retriable error types. You practically explicitly say don't retry this error, and in the retry policy. Other way to do that is that you in the code you can practically say application new non-retriable application error, and this error will not be retried even if it's not in the retry policy. So it's up to you how you do that. So practically activity can decide return an error which is not retriable. In Java, it obviously will throw exception. In Go it's just return error. Or you can have error which, if you have somebody else's activity which you don't control, you can in retry policy say don't retry that specific type of error. By default, unknown errors are retried. And yeah, that is kind of. Does that answer your question?
Yeah. One more follow-up question. So it sounds to me like you're pretty much the heaven for process miners, because I feel like process miners are all about encapsulating business logic without caring about things like resilience and so on at scale. And it seems to me like you can put any business execution in there and it will run resiliently, basically, right? How does it work when you want to integrate it into maybe a BPMN engine or something, right? You have something like car manufacturer, and the car manufacturer is like thousands of processes that they want to interconnect with the workflow engine, right? Would they have to use the SDK then to integrate it into their BPMN framework, whatever, or how does it work? So basically, I've heard from you now, you used it in production, you have one server basically that just gets all these calls back from Temporal that executes the logic on the worker, right? Would it be then in a way that you implement all of these calls basically as single processes on different backends, and Temporal just gets the call from the process engine and you get the call back?
So in this case, Temporal, no, it's a bit different. Remember, I talked about DSLs, right? So when you say you have a DSL, you can interpret this. You can just write workflow, which will interpret DSL. So if I wanna, for example, you come to me and say, you know what, I have 10,000 BPMN workflows in my world, and you cannot go and rewrite them tomorrow to Temporal. You can write interpreter of BPMN in Temporal, right? And then you will be able to execute all BPMN on Temporal. They will just Temporal workflows. You don't need existing BPMN engine. You probably need parser, because parsing the XML beauty of BPMN, like I don't want to write it code, but probably you can find framework for that. But you absolutely can do that. Practically, you can take any existing workflow engine and write interpreter to run it in Temporal.
And then maybe taking it back to the Kubernetes piece, that means I could write an operator that just calls you and updates the state of a resource based on the workflow.
You could do that absolutely. Because it doesn't need to be workflow, because I didn't show you, but you can absolutely send event to the workflow called signal. It's asynchronous. So practically, in Go case, it just puts in the channel, and inside of the workflow, you can listen to the channel for external signals, and you can react to them asynchronously if you want to. or you can have separate routine listening. So how much time do I have? Because I can go in for another 3 hours.
Pizza is there.
Yeah.
It's getting
I just want to make sure that
colder,
I don't.
but I actually want to see the demo to the end.
Okay, let's do that. Let's do that, and we can talk. Yeah. So practically, we started instance. We waited it to start, right? But let's do more thing. Let's say I want to wait for this instance to disappear, right? So I don't want my workflow to. Practically, I will wait for state not found, right? Let's redeploy code. And run this workflow again. Let's look at our workflow. It's running. And let's wait for it to get to the state of so we are waiting for state. Which state we are waiting? Oh, it's not showing input because I need to.
What's state running?
No, I can see it here. So I wait instance state, I scheduled, here's the input. We are waiting for not found already, right? So we can go and nicely kill it, right? Okay, I didn't kill the previous one. It's good that none of it cheap. It's actually my personal account. Okay. Killing.
Well, it should still be found, but with the state terminated.
Huh?
Shouldn't it be still be found with the state terminated? instead of the
For some
state?
reason, no, it's exactly what I expected when I wrote this demo, but it looks like it just returns empty list back.
Okay.
It's actually, I don't know why, but we do that. I worked for AWS, but it was a long time ago, so we cannot do anything. So let's look at our workflow. Completed, right? And we like it finished, right? So just to make it more concrete, you now you probably understand. I can go and do the following thing. Say 2.
But now I wonder, when you terminated the instance, it was according to the UI still not initializing. So it never reached running.
No, it would. What do you mean?
When you were on the UI and terminated the JVM, for instance, it wasn't state initialized.
No, it was, but it was waiting for running first. This workflow wouldn't complete because it would wait for its running, and only then I killed it, right?
Okay.
Yeah, and again, I'm not saying it's robust demo, like don't put it in production, please, right? But basic idea, you can have workflow which manages instance, and obviously, if you think about workflow, AWS auto scaling, what do you think it was using? Simple workflow, right? So these things are, you can practically write auto scaling groups and all these things, and half of Kubernetes functionalities is a bunch of workflows pretty directly. But I put a loop, right? So let's try it again. We deploy. Other thing is that this code doesn't need to run to be able to start workflow. Temporal should run, right? It's queued. There is no requirement that your workflow should be running. It will still accept the start request. Let me even show that. And in this case, we can also troubleshoot that in UI. So if we go to the UI, we see this running, but our history will be very short. Workflow task scheduled, right? So workflow execution started, workflow task scheduled, nothing is releasing workflow task, so there is no workflow worker running, but very easy to troubleshoot. So let's run the worker. Oh, there is one more thing just to show you. When we are troubleshooting that, there is this task queue thing, which is queue list. You can click on that, and it will show me the list of processes which and when they last polled. So you can actually find, oh, nobody's polled, right? Or this very common problem. Somebody starts process, kills it, but kills it like not cleanly because it's very easy when do local development. Then starts new process, and then like task never hits it. oh, it's a bug or whatever. And then like I always look identity, and you always find the identity of like this that process which actually got the task and then did process it. So it's a kind of you use identity of these processes just to, and production identity will be obviously your port or whatever. You can assign it whatever you want. When you initialize worker, you can put any like application specific or your info specific tag there. So we should have something running. Running, right? Let's kill it. No, doesn't work. Let's troubleshoot. What we're waiting for? Not found. Let me. I hate when we sort it backwards. I don't know why we do that. There is actually short view. Let me see. Okay. Run instance, await instance state, run this new one. Why didn't you see it? Oh, okay. There is instance running. So it restarted that, right? I terminate that, it restarted. So if I terminate this one, as we had two, probably it won't, it will not restart it again. But you get the idea. Other thing, one more thing to show is that workflow state, you want to know about workflow state. So you actually can set query handlers inside of your workflow function. Oops. So practically you just no. Oh, a second here. So practically you can set query, you can set as many as you want, and it can return anything practically any structure you want. And this is the way you practically can synchronize request into the workflow. So from outside for CLI, API, or through the you practice say query, and it query blocks, API call blocks until it hits workflow, calls handler workflow. It cannot mutate state, but it can return any information from workflow. So you can actually synchronously query any information, and you can put any code there. And in this case, it's instance ID. So just to show you that, let's restart the worker. And if you go here, should be able to go to queries. This is instance ID. So there is other things, signal. I'm not going to show you. I don't have time. But practically, I can have open channel. It's a special interface. You have to use our interface for channels and go routines. But you can open channel and say signal name, and then you can call outside signal events to that workflow, and it will practically receive them. And you can take any practically your workflow asynchronous can handle any logic. So in this case, for example, I want to change instance type, right? Just in signal, it will kill the instance, restart it, right, with a different type. You can do that practically, just keep coding this state machine kind of type thing. All durable, you need no database calls, no durable types, and so on and so on. That is, and one last thing, probably testing. You can just go and test this thing directly. And you see test passed, and I can mock activities, right? I practically in this case say when it calls this, return instance ID. You can do like normal mocking, validation, all these things. The coolest part about testing is that let me just do one thing. Let me just go and put here time hours, 10 hours sleep. Question is how long workflow test will run. immediately. Why? Because if you look here, it will say skip 10 hours. So practically, our unit testing framework automatically detects that your workflow is blocked on some timer and will forward time. It includes child workflows and everything. So we have child workflows. So practically, you can have very long running workflow. You don't need to do any mocking of your timers or whatever. You can absolutely unit test long running workflow in milliseconds because automatically it tests and does time. Okay, that was the demo. Sorry, I wasn't like rehearsed.
On your laptop, basically, when you run, where's the temporal?
Oh, yeah, I
structure?
forgot. Thanks for this question. Actually, so there are two ways to run it locally. I use Docker Compose. You practically just go in, there is a Docker Compose repo. You do clone that repo. There is Docker Compose file. There are multiple configurations. You just do Docker Compose up. In like a minute, you have a full temporal running on your machine. Some people cannot run Docker Compose or hate it for all sort of reasons, just memory and or whatever. We actually right now, the DataDog team contributed Temporal Lite. So practically we have Temporal, which uses SQLite, because Temporal has bindings to multiple databases. The other cool part is that this code will run if you run Temporal with MySQL. It will run if you run Postgres or Cassandra or Temporal or SQLite. You don't need to change line of your code. Right? It's just underlying implementation detail. And they did my SQLite. So practically we have single binary version, which includes database, which includes UI, and practically full featured binary. You can practically do develop. It's not super fast, but for developing is good enough. In this case, Docker Compose. And it's all local right now. Yeah. A couple of things to mention in general is that Temporal cluster, you can run it, and but we obviously provide cloud service. It's the way we make money. And the only way we don't do any like we do MIT license. We don't want to change it ever. We don't want to play these games. We don't do open core because it creates like bad incentives to kind of put features there. So open source is fully featured. Our cloud is just running cluster for you. You don't run your code. Actually, which is cool for security, all sort of other reasons, because you can encrypt every payload you send to us using your encryption. Like all security guys are pretty happy about that. And then and you control your workers. We don't run your code and so on. And then we charge our cloud is consumption based. So practically we charge, I don't know, like I think like $10 for million activities or something like that. It's pretty cheap. And also we have huge discount if you run very high rates. So like if you start running like 10,000 actions per second or 100,000 actions per second, there is a 70% discount there. That is a question.
Yeah, what is the most surprised use case you have ever seen using Temporal? A use case that you never thought of will benefit.
The interesting one in Canada, there is a small startup. They are doing archival, and Norway has this Norway project practically keep medical record of every citizen forever. But you can go there and say, because after you can come and say, you know what, can you show me all medical records of my grandfather and like all my family? And they, because all sort of health reasons, it's kind of very useful information. So they practically have the whole system to kind of accumulate that, archive that in physical practically, and put it somewhere like in some vault in the middle of some mountain, like thermofrost type thing, like some insane stuff. And there is practically these guys are doing archival and they're part of that project. Other one which they mentioned, I have no clue if they got that, but they actually were bidding to do archival for like European Union documentation. And they do a Library of Congress of US. They took Temporal because they like it's open source and all these other things because they don't use other. That is one. There are a few pretty cool IoT use cases, I think. Then what was like the an obvious one? So many business processes, like there's nothing like super cool. Yeah.
System has some UI and entry points. I'm sure you've been questioned how do you secure that? Like, what's your authentication and authorization scheme? It's all with Temporal.
So UI is using a kind of, I'm not expert that, I probably say something stupid here. But it's updated into tokens, so this kind of standard like authentication. I think right now they integrate this Google authentication. If I go there, okay.
OpenID.
OpenID, I don't probably. Like, for example, for our cloud UI.
What about authorization then?
So we use internally. It depends. Open source, it provides plugins. You have to write your own because it depends on your company. Everybody does differently. I think for like authorization.
So
For in the cloud, we have our own infrastructure, has our back and like different roles, and so you can kind of manage them. So in this case, you see this is our cloud test instance. I just continue with Google and log in there, right? And then I can manage users, I can manage permissions and whatever. Okay, so looks like I'm kicked out.
So
But
that's more of a bring your own solution kind of thing.
for open source, yes. No, for I think for web part is already kind of pretty integrated with whatever like providers are. But for the cluster, yes, because everybody does it differently. There is, I think, plugin which you need to write in Go. So then you will need to do your own binary. So practically, open source written in a way that you can override different parts of the system, like the metrics provider, right? Login, whatever, like authorization, all these other things. So you practically just extend them to cases and as options, and then you can do your own binary. Good.
I have one more last question.
Okay. So I'm curious about how the code base evolves while you're using the portal. So
Okay.
let's say because the topic was infrastructure provisioning, right? So I want to provision my infrastructure. So in order to scale, you need to create a VPC, then a subnet, then go and create some translate some external addresses. So and I need to do this conditionally, right? So I can only go and create a subnet after I create a VPC and other. So how would that look like, right? Because here you only create one chunk. So I can imagine that there would be an executor bit where only creates VPC, then I have one that creates a subnet, but then I need to combine it.
This is code. You can put if statements, right? Switches, like whatever. It's just code.
Okay.
So you say if whatever, like think about so the mental model.
I'm great example, right? So we use OpenStack, right? And we use OpenStack, and you know, we use OpenStack.
Okay.
So and when you provision something, you say, okay, I want to create a VPC that has a name, right? Let's say it. And it allows duplicate names. Okay, so and I can only discern the thing that I create from the ID that I get back after the call. So I imagine if I use Temporal, I would need to create something for the VPC first, and then have another executor like activity that creates then subsequent resource that will do that. So then if I have to create a whole workflow that uses that, then do I need a meta flow that calls other temporal workflows? You know what I mean? So
You can also do that. They call it child workflow.
okay, so
Like obviously I say execute activity, you can say execute child workflow and okay, child workflow, like there is no limit how many levels of child workflow. And then you can go to parent and say kill the whole thing. Like for example, you need to run million activities. Workflow by is limited size. Like we don't scale up like the workflow size because we record events and whatever. There is limit. Workflows cannot be huge. Then if you need to run million activities, you're not going to say, oh, load million activities and do for loop. You will create 1,000 children. Each of them create 1,000 children.
the important part for me was that if I need to start making more complex activities, that then potentially use other activities. So how that the
Activities cannot use activities. Workflows can use workflows. So practically, we don't recommend you doing complex activities because activities should be like an atomic unit of work with one thing. And then you break your kind of business logic in a lot of small activities, and then workflows are this later.
May I suggest one thing? I think you also have to go to some other place today,
Okay.
but the pizza is getting cold. Maybe we can, if Maxime still stays with us for another 5-10 minutes, then you can ask the question directly. But again, give Maxime please a hand. This was awesome.
One thing is that Temporal is an open source project. We means that you go to Temporal.io, you go to join our Slack, you can find me there like anytime, like I'm always there. Like we have community forum, like find our team and reach us is very easy. So if you start using that, you have any questions, you just like, it's not like a go back to US, you never can find me. So we are there, like just to check it out. Okay,
Thanks a lot.
Thank you.
There's some immediate feedback here. I know at least 2-3 guys who are gonna now download this and try it out.
Yeah, please.
Just from the housekeeping, one housekeeping